Okay, so the first step to solving these is to understand the equation we're using. We find the area of a rectangle. Area of a rectangle is what? Base times height, but I guess in this example it's length times width, same thing. One number times the other number. Okay, so the logical way to solve these would be say, okay, we have two numbers that have to multiply together to be 12. What two numbers can those be? To 12. 3 and 4, 6 and 2, 1 and 12. All three of those work. We're going to choose our favorite one. I don't know, which one do you want to choose to be your favorite? So 6 times 2 is equal to 12. You know what? I'll show you. 1 and 12 works too. I'll even show you. Okay, how about 3 and 4? That works too. All of those work. Those are our old dimensions. What are we multiplying them by? Well, we're multiplying the first one by 2. Twice as long. Twice as big as 1 is 2. 3 times as long as 12 is 36. So that's equal to 72. Twice as long as 6 is 12. 3 times as large as 2 is 6. 72 again. Can anyone guess what this is going to end up being? Twice as long as 3 is 6. 3 times as long as 4 is 12. If you look at that, 72. Okay? So the point I'm trying to make there is it doesn't really matter which numbers you choose, as long as they multiply to be 12. For now. You can keep it. For now. What do you get? The shortcut has to do with them not having to be multiplied to be 12. All right. The next step you would do is you would find the ratio. Well, we know the ratio is going to be the the new number divided by the old number. New number is 12, 72. Old number is 12. That is equal to 6. Same thing. 72 divided by 12 is 6. 72 divided by 12 is 6. What does that mean? That means the new ratio is 6 times as large as the old one. So 6 times 12 is 72. So we know the new area is going to be 72 centimeters squared. Okay? Now that's the proper way to do this. There's a big shortcut you can use. But in order to do the big shortcut, you have to understand something. First thing I'm going to do is I'm going to erase all this for now. Okay. First thing I'm going to do is I'm going to start with the same formula. Instead of using two numbers that multiply to be 12, I'm going to say choose two arbitrary numbers. Any number you want. Just choose any two numbers you want. 3 and 7. Okay. Let's do 3 and 7. 3 times 7 is equal to 21. 2 times 3 is 6. 3 times 21. 21 times 6 is... Put it in the calculator. Is that it? He was right. 126. All right. New divided by old. So do 126 divided by 21. Oh. So the ratio is still 6. And we chose two random numbers, right? Okay, now let's be smarter. Let's actually be smart about the numbers we choose. Exactly. We're going to choose 1 and 1. Why are we choosing 1 and 1? Because any number times itself is, any number times 1 is itself. So, in mathematics, the two easiest numbers to use are 1 and 0. So if you ever have the chance to choose any numbers, you either choose 1 or you choose 0. Can we choose 0? No, we can't have a width of 0. It's non-existent. So we're going to choose 1 and 1. 1 times 1 is equal to 1. 2 times 1 is 2 times the length of 3, which is there's your 6. And since we chose 1 from up here, it's just 6 divided by 1. And then remember, you take this and you take this as your scale factor and multiply it by the original starting number, right? The original area. You get 72. So 6 times 12 is 72. So here's where the shortcut comes in. Because we can choose 1, we know we can take this number, 12, and multiply it by its scale factor. 2 times 3. That ends up being 72. That will work for every single problem except there's one exception to it. So let me show you the shortcut in action, how much quicker it is. 3. Take the original number, 16. Multiply it by the first one. 3. Multiply it by the second one. 1/4. 16 times 3 times 1/4. Well, 1/4 times 16 is 4. 4 times 3 is 12. It's going to be, the new area is going to be 12 inches squared. All right, so I want you guys to try doing number 5. Okay, try doing number 5. You don't know how to do it? I would start by reading the problem. You'll be able to find 3 numbers. There's 3. All right, so since we're off topic now, and that's kind of funny because I see blank papers. First number, the original number, 36, multiplied by the scale factor. Well, we know 1 is tripled. Tripled means times 3. And the other one's kept the same. 1. Third number, keeping it the same means it's just 1. 36 times 3 is 108. Was that bad? Because I'm doing odds? No. Exception circles. All right. Try doing number 7. What are you supposed to do? It stays the same. Think about it. Okay. Think about it. You take one edge and you double it. Take the other edge and you half it. Cancels out. Right? Yep. So 52 times 1/2 times 2. 1/2 times 2 is 1. 1 times 52 is 52 inches squared. Okay. So let's see who here is extra smart. Who knows why that's weird? Other than it being other than it staying the same. Why is that weird? Yeah, but that's why it's the same. But why are specifically triangles? Why is this working for triangles? Yeah, because I thought the triangle formula. Let me try to find one. Okay, let's look at this problem, number 11. Okay. Why is this weird? Well, first off, I thought the triangle formula was 1/2 base times height. Right? And we know the shortcut is 300. Let's not do this one. Let's do a different one. Try. I'm not wearing my ID. All right, let's change this instead of halved. Let's change it to quartered. Okay. We know the formula is 1/2 base times height. And then the shortcut tells us it's 300 times 1/4 times 3. What's missing? The half. Yeah, where did it go? And I'm telling you, that's the right answer. If you were to do this times 1/4 times 3, you'd get the right answer. Yeah, that's the right answer. So where did this 1/2 go? Nope. Is that the answer? You're saying 225 times 1/4 times 3? Okay. Okay, so no one's answering my question. Where did this half go? Mm-mm. Because I wanted to show that the half disappears. Nope. Nope, it's not replaced. No. Mm-mm. So you guys give up? Okay, let me show you where it goes. So I'm gonna do the shortcut method, right? We know it's going to be the original on bottom. The original is 1/2 times base 1, which we're going to call 1, right? Times h, which is 1. One second, I'm waiting for everyone to catch up and pay attention. Okay, so this was the one with the ones, right, where we plugged in ones. Now we still need to multiply. We still need to do the ones with the new one. So 1/2, because that stays the same, times 3 times 1 times 1/4 h, which is 3. So 1 times 3 is 3. What canceled out there? This 1/2 canceled out. And then 1 times 1 cancels out there. So that's why this gets plugged in there. That's why the 1/2 disappears. We divided it out. It cancels out. So I'm going to tell you, any constant, and constants are non-variables, right? 1/2 is the constant in the triangle formula. Constants are not affected by rates of change. That's why they're called constants. Who can think of another constant in an area formula? Pi. Pi r squared. Pi is the constant. Your pi is never going to show up in these problems. Okay? All right, 13. A right triangle. Oh, actually, I want to do 12. Okay, a triangle has 375, an area of 375 centimeters squared. Its area, find its area if the dimensions of all of its dimensions were reduced by 1/5. We need to figure out how many dimensions there are in a triangle. We know the formula is 1/2 times base times height. We just discussed 1/2 is a constant, right? Is a constant a dimension? No, it's not. You can't change the constant. But you can change the base and you can change the height. So how many dimensions are there? 2. So how many 1/5 do we have to multiply? 2. So that's going to be the formula. We're going to have 1/5 times 1/5 is 1/25. Yep, it's going to be 15. All right, find the area. If the area of a parallelogram is 108 squared centimeters, what will its area be if its dimensions are reduced by 1/3 of the original length? So we know there's 2 dimensions, base and height. So 108 times the base, which was reduced by 1/3, times the height, which was also reduced by 1/3. 108 divided by 9 ends up being 12. That sounds about right. All right, these ones are actually easier. It asks how does the area change? So now we're trying to find the scale factor, right? So we know the base and the height of a parallelogram are both multiplied by 4. So we know it's going to be the base times the height, right? Oops. Which is 4 times 4. So we know that the scale factor is just 16. So it's actually one less step to these problems, right? So it's going to be the new area is going to be 16 times larger. Yeah, if asked describe the effect, you have to write 16 times larger. Now here's the exception, circles. Well, remember I said pi's are constant, so we don't worry about them. Okay, if you use my shortcut, you say, okay, easy. We have a radius of 4, so just do, okay, times 4. It will be 4 times as large, right? Because there's only one dimension to a circle. Well, it's actually going to be 4 times 4, but why? We only have one dimension here, right? And that's the radius. So it should only be times 4, because we only are increasing one thing. Right? So, times 4. That area is going to be 4 times as large. The formula is pi r squared, which can be rewritten as pi times r times r. So you got to double up on those r's, right? So it's really going to be 4 times 4. This r times this r. So it's going to be 16 times as large. Yeah, because the pi is a constant. The constants cancel out. 16 times as large.